commercial pig breeds, which are resistant to a virus which wreaks havoc on the industry. That company now hopes the United States Food and Drug Administration, the FDA, will give the green light this year for human consumption of that pork. And this could pave the way for other livestock like beef to follow suit. I'm joined live now by Alison van Eenenam, an animal genomics scientist. How'd I go there with the surname?
You did it perfectly. Well done.
Thank you. Now, this is fascinating stuff. Start out by letting us know, what is gene editing exactly?
So gene editing refers to a relatively new, about 10-year-old technology that enables you to go into the double-stranded helix and make a targeted deletion. And basically you can inactivate a gene, so DNA makes protein, makes the gene. So you can inactivate a gene that, for example, makes a pig susceptible to a virus.
So if we look at what this company has particularly done, explain a little bit of that in simple terms for us.
Sure. So there's a virus, it's called PRRS for short, porcine reproductive and respiratory syndrome virus, and it's a devastating virus. It's not only respiratory, but it also causes abortions, and it's very costly to the pig industry. So basically this company has used genome editing using CRISPR-Cas9 to knock out the gene that makes the protein where the virus gains entry to the pigs. So those pigs are no longer susceptible to that particular virus. They're virus-resistant pigs.
So what kind of hoops do they have to get through to get the green light from the FDA?
Well, basically they have to show that they did the intended edit and that there's nothing different about the meat. It's safe to eat and that the pigs are fine and running around, and the only difference is that they are resistant to that virus.
So if this does get the green light, the rubber stamp of approval as such, what could that mean, I guess, for other things to get through?
Well, actually, it's already got the green light in both Brazil and Colombia, and there's actually gene-edited knockout fish on the market in Japan, 3 different species. So they're starting to get through. There are some gene-edited animal products commercialised and available to consumers in Japan.
Are there any with beef yet?
Not with beef yet. There has been 2 animals that have been edited for knockout that creates the SLIC mutation that you can see in some breeds of cattle. And that actually has got the ability to be commercialised in the United States, but it's only 2 animals. It's not a full animal drug approval.
So it all sounds very simple from a basic point of view in the sense of, well, they've done this thing, it has these benefits, this is what it could do. What's the public perception of gene editing?
Well, interestingly, we have Japan as a case study, and there was no pushback because basically they like their fish, and these fish get to market in less time than a conventional fish that hasn't been edited, and that's good for the producer, obviously. Less feed, less environmental impact, and the consumer gets a fish that they like. So there hasn't been any pushback at this stage. Of course, I anticipate that the anti-GMO groups will try and create fear around this technology, but it's very different in my view to kind of traditional GMOs where you're introducing a novel, transgenic DNA. You're just actually tweaking the DNA within an animal to make it virus resistant, and that's kind of a triple win for sustainability. It's great for the farmer if the animal doesn't get sick, great for the animal if it doesn't get sick, and great for the environment if you don't have dead animals. So it's a rare trait where you have the triple win.
Do you see a time when we could all be eating gene-modified meat?
I would hope so. I think there's some really useful traits we could introduce into beef cattle, for example. That the trait to not grow horns would be really useful for the northern beef cattle population. The SLIC mutation for heat adaptation and disease resistance. I think there's a couple of different examples for bovine respiratory disease that people are working on to try to make animals resistant to things like pestivirus. So I feel like there's a lot of opportunity here, and yeah, we could not solve these problems with gene editing, but that hasn't solved the problem. So we have a technology and an innovation here that could help. With that, let's use it.
Are there any drawbacks?
Well, I think the difficulty actually with this technology is global regulatory harmony. So let's say that the Office of the Gene Technology Regulator in Australia doesn't treat knockouts or gene switching off as different to conventional breeding, because it's just genetic variation at the end of the day, and that's what breeding is based on. But what if, for example, one of your major export markets like the EU says, oh, no, we're going to have this really expensive, complicated regulatory approval process, then, the big companies are going to be hesitant to use it in Australia because they don't want to jeopardise their export market. And so really getting regulatory harmonisation, I think, is probably one of its biggest challenges.
How do you overcome that?
Wow, I wish I knew. I mean, the way that the UK company has approached it is they're getting regulatory approval in what I would call sensible countries that are not, they don't have.
Well, give us your list. Who are the sensible countries?
Australia's on that list. So Brazil and Argentina, Japan, so that aren't treating knockouts or gene inactivations differently to conventional breeding. And they're getting approvals in those countries, and China, one of their major, obviously pigs, major export market. They're not even bothering with Europe. They'll just leave the disease-susceptible pigs for the European consumers. And to me, that's not moving in the direction of sustainability. So blocking innovation from being used in agricultural production systems has this real opportunity cost as it relates to sustainability. And in the case of this technology, where there's no novel risks associated with DNA variation in your food, it doesn't make sense to have a really arduous, insurmountable regulatory pathway. It should, as the Office of the Gene Technology Regulator does here, say, okay, anything novel, has it here, and if not, then move forward. And that's the approach that's being taken.
Why is the EU that way?
Wow, that's a difficult question. That they've got a fraught history with GMOs particularly. They have some very strong, they call them civil society groups like Greenpeace. I would call them uncivil because I actually think they've blocked progress. They've just recently been able to block the vitamin A golden rice from the Philippines to get to kids that have vitamin A deficiency and will go blind. And to me, that's not a civil society group. That's a group that's actually working against the interests of humanity, and I find it reprehensible that a well-fed country can dictate to a developing country that's trying to feed its people what breeding methods it's allowed to use.
What's at stake here? What happens if the world doesn't move in this direction?
Well, I guess you could look at more generally. Let's just say 1940s, we banned artificial insemination because it's artificial and it sounds a bit dodgy. And actually, there was a little bit of pushback back then. But I look at a glass of milk today is a third of the carbon footprint it was in the 50s because, well, genetics, better feed, better veterinary care, but it's a third. So what if we hadn't had AI approved, artificial insemination, not artificial intelligence? Then we just have more cattle and a higher footprint, and that goes against the shared interests of consumers and producers. And to me, it makes no sense. So, if blocking innovation from getting used in agriculture has really, really profound opportunity costs. And I think that if that happens, people need to own the increased carbon footprint associated with that choice. And that, to me, is, Europe says they're really interested in improving sustainability, but then their behaviour doesn't demonstrate that they're interested in actually doing that.
There seems to be a running theme we're hearing across a lot of areas when it comes to that throughout this week. Alison Van Eenennaam, thank you so much for your time today.
Thank you, Andrea.
Well, we are off to a break, but on the other